I'm Minoli Perera. I'm from the Inclusive Technologies group at Monash University, which is a part of Monash Assistive Technology and Society Center. On behalf of myself and my co-authors, Bongshin Lee, Kyoung Choe, Kim Marriott, I'm presenting our paper, Visual Cues for Data Analysis Features, Amplify Challenges for Blind Spreadsheet Users. Spreadsheets are widely used for storing, manipulating, analyzing, and visualizing data. When accessing spreadsheets, blind people use a screen reader. The standard presentation is for the screen reader to read information cell by cell, providing the cell value along with the column and row coordinates. Spreadsheets also offer the flexibility of having multiple tables in its two-dimensional grid. Prior research has found tables, whether in spreadsheets or other formats, to be challenging for screen reader users to understand due to cell-by-cell navigation. They find it difficult to identify the overall structure, patterns, and trends in the data and experience high cognitive demands. Most prior research into spreadsheet accessibility has focused on evaluating proposed solutions rather than understanding user interactions with spreadsheets. They have used sonification, haptics, and hierarchical navigation to support the understanding of tables and charts. Most of this research is more than a decade old, even though the spreadsheet tools have evolved significantly over the years, adding new features to enhance their capabilities. They are now equipped with powerful features such as conditional formatting, formulas, sorting, and filtering, which play an important role when understanding and analyzing data in spreadsheets. These features add an extra layer of information to the table data and heavily rely on visual cues. While sighted users can extract this information at a glance, we have little understanding of the experiences of blind screen reader users. To address this gap, we conducted a remote study with 12 blind spreadsheet users. Specifically, we aim to gain insights into the main challenges they face and strategies and workarounds they employ to overcome the challenges. We started with an open-ended exploration task. We give participants a real-world scenario which required spreadsheet use in a workplace context. We told participants to imagine that they are working for a chocolate sales company and were a member of a team responsible for analyzing chocolate sales data. We told that a sighted colleague had previously conducted an analysis of the sales data and created a sales report in a spreadsheet, and the spreadsheet was shared with them to review before sending it to their manager. In addition, we told them that their manager was blind and they needed to provide descriptions of the spreadsheet and its data, including the structure and important patterns, insights, and high-level summaries from the data. Then we sent the spreadsheet via email to be opened with Microsoft Excel, and we requested the participants to share their screen. The sheet consisted of 3 tables. The first table displayed profits for multiple products across 6 regions, including the overall profits. Conditional formatting was used to highlight losses. The second table showed the sales performance of 20 salespeople along with their individual sales targets and an icon indicating whether those targets were met. Data bars were used to facilitate the comparison of sales data. The third table had quarterly sales data accompanied by formulas giving totals for each country and quarter. The total for quarter 3 contained a warning as it didn't sum all regions. The total for Canada contained a syntax error, which also resulted in an error in the overall total. After completing the exploration task, we told the participants that their manager had posed specific questions regarding the sales data. These questions were created with the intention of capturing interactions with particular data analysis features that the participants might have missed during the exploration task. Once the participants completed both tasks, we conducted interviews with the participants to get more insights about their experience with navigation and feature usage. We conducted two separate analyses for the screen recording of the exploration and follow-up task and for the interview responses. Overall, our result shows that participants found it difficult to understand the spreadsheet and complete the task. Only one participant found all three tables in the initial exploration, and all participants made at least one mistake when answering follow-up questions. Participants used multiple strategies when completing tasks. I will mention the most common ones. To figure out what the spreadsheet contains, most participants used a mix of sequential traversal of rows or columns and horizontal jumps. For example, once they had found the first table, a typical strategy involved exploring the cells to the right of the first table. After they encountered a table, participants tried to understand its structural layout by visiting column and row headers and some data cells. The most common strategy used by participants when they encountered an error cell was to reveal the formula and to navigate character by character within the formula to understand any issues. They fixed the formula error by typing or copy-pasting the formula from another cell in the same column. Some follow-up questions required identifying cells that satisfy certain criteria in one of the tables. The most common strategy was to use sequential cell traversal to explore the relevant regions of the table. For instance, participants were to identify products that were generating losses along with their respective regions. Most participants used a sequential cell traversal approach to locate negative values. Only a few participants used sorting and filtering to derive the answers. We found four main challenges users faced when understanding and extracting information from spreadsheets. Participants found it difficult to find content on the spreadsheet. Two participants missed the second table and only one found the third table. Participants mentioned that finding content in unfamiliar spreadsheets is difficult and time-consuming due to cell-by-cell navigation. Some participants misinterpreted the structure of the tables. They interpreted table 1 and 2 as a single table with blank columns between the two. This resulted in providing incorrect information about the table structure and the meaning of the data. Participants found it difficult to identify and understand information conveyed through visual cues due to multiple reasons. One reason is that they did not visit the cell with the visual cue. During the exploration, some participants did not know about the existence of errors in the sheet. The second reason is that the screen reader did not announce the presence of the visual cue when the cell was visited. Even though the cell which contained the warning had a visual indicator, the screen reader did not provide any indication when the cell was visited. Even if the screen reader revealed the feature, participants struggled to understand it due to their unfamiliarity with the feature. For example, participants were unfamiliar with data bars and were confused in determining the underlying basis of the percentage values. The lack of information about the conditional formatting was another issue. In the first table, even though the screen reader mentioned the cell contains conditional formatting, it did not convey information about the highlighted cell's condition or the style. All cells in the table were read the same. Creating and correcting formulas was challenging because it required participants to visit cells and memorize cell references to input to the formula. We identified 5 underlying reasons for those challenges. Cell-by-cell navigation creates high cognitive overload when trying to identify trends and compare data values. Participants found it difficult to remember keyboard commands to perform actions. When navigating data cells in the table, they found it hard to remember the related table row and column headers. Extra verbosity from the screen reader was frustrating to participants. For example, icons were disliked as it read the icon type and the color, which was not very useful for the users. They preferred having just text, such as yes or no or icons. Participants said that they avoid going through ribbon menus as they found it difficult to go through multiple menu items to find relevant features. Participants were unaware or unsure of some features. This prevented them from benefiting from them. For example, the participant who discovered the third table used the navigation pane feature, which listed the cell references of the data ranges in the sheet. This feature could have helped more participants to find the third table. Participants showed less confidence in using features such as sorting and filtering as it did not provide adequate feedback to them. Participants reported experiencing high latency from the screen reader when reading content in spreadsheets. Also, they said that the screen reader gets sluggish when writing complex formulas and accessing large spreadsheets. As mentioned before, some content was not even read by the screen reader. Based on the findings, we discussed design considerations aimed at improving the experience of blind spreadsheet users. We found that there is a mismatch between sighted and blind users' layout preferences. Even though the sighted users values the flexibility of the grid, blind users prefer data be more structured. For example, most participants mentioned that they preferred having one table per sheet to have data from the first cell and to remove unnecessary blank cells. We suggest that sonification and audio cues could be utilized to reduce extra verbosity of the screen reader. A readily accessible overview, which includes information about the objects in the sheet and information about their features, will be beneficial to blind users. We identified that recent advancements in AI, such as large language model based tools, have potential to mitigate and offer novel solutions for addressing the identified issues in the study. They could answer questions about the objects in the sheet, existence of different features, and provide information regarding table data. The ability to apply contextual information to data will help screen reader users intuitively extract information. Also, the ability to provide commands in natural language would reduce the necessity for screen reader users to remember a large number of keystrokes and navigate through multiple menu items to find features. Thank you. Please refer to our paper for more information.